Okay, this is Dr. Kristen Stewart from Marketing Research 442, and this is the Key to Stats 101 practice. So over here is where I've got my actual homework assignment. This is the week 10 readings posted, and this is the spreadsheet that I provided for you to help you calculate these values and just understand where they come from. We're going to talk about each of these statistics later, but really I just wanted you to get an understanding that confidence interval is when you estimate a population parameter. Remember, we care about the population, not the sample per se. And so we do this so that we can estimate a range of values for the population mean or proportion, which could be a percentage. We calculate those values, and then we see how our sample mean measures up. And when our sample mean falls, this is our sample right here. So when this falls within the interval, we can then be confident that our intervals contain the true population parameter, okay, using the confidence interval. So let's give it a try. I'm just going to go ahead and block this one out. We're not going to do sample size determination for now, so I'm just going to black out these sections. It'll help you guys not get confused. Okay. We're not going to do the 95, or we're not, I think first one requires that we do a 90% confidence interval, so we're going to just black out this one real quick. Okay, so I know now that I'm going to, don't worry about these values and so on and so forth. So I know now that I'm going to calculate a 90% confidence interval, because when we read through this whole practice brief, it basically said find a confidence interval for the proportion of college students who do prefer drink A. So up here we have in these columns the confidence interval of a proportion equation. P is the proportion. So if 30 out of 150 preferred soft drink A, what proportion of is that of 157? Okay. Well, this is weird, Professor, because this says mean exactly. Good. So at the bottom, you'll see that there's a mean and a proportion one. So you want to then bounce over to proportion, and again, we're not using this one right now, and focus on proportion. So basically, I just told you that this P is the proportion, and that goes here. And then you'll see I have 1 minus P here, and that's part of the equation here. You see I have N, that's part of the equation here. Then I actually do the statistics, right? I do the P times 1 minus P, then the next thing I do is P times 1 minus P over N, right? And then the last thing I do is the square root of that. Please note that this is using the order of operations. Revisit PEMDAS if you need. So like I said, this P should just be 30 over 157, because again, it's 30 who prefer soft drink A, and I'm interested in the students who prefer soft drink A. So then 1 minus P is calculated for me at 81%, okay? And what is my sample size? It's 157, not 159. How do I know that? Because it says right here, 157 college students. Last, I know I'm doing a 90% confidence interval, so that means I need to make sure my Z statistic is correct, and it is, and we'll talk about that in class. Then it calculates for me the square root of everything, which is 3%, okay? And lastly, it gives me, I'll block this out for now, and lastly, it gives me my confidence interval of 14 and 24%. So some of these values will auto-calculate because look, I've built the equations, right? P times 1 minus P, that's what's required here. And I said that you need to take that P times 1 minus P over N, and that's what I've done here. And then last, I've said you need to take the square root of that whole function, and look, there's the square root there, and that's what I've done here. But then lastly, it says then I have to take my original proportion and plus it to that whole order or that whole equation, and then minus it from that whole equation. So you'll see that this is minusing my 19% from it looks like, oh, sorry. This right here then is the last part of that equation, which is to multiply the z value, the c squared, to the whole operation. So this is what we're dealing with, which ends up being our margin of error. So then what I've done now is I've taken 19 minus that, and then I've taken 19 plus that. And so what I then go in and say is that the confidence interval is 14 and 24. And one of the ways that we interpret that is to say, see if I can scroll down and find that for you so you can read it. I don't see it on this sheet, but the way that we interpret it is it's saying that we are 95%, or 90, sorry, we are 90% confident that the population mean lies between 14 and 24, okay? And because 19 lies between 14 and 24, we feel good about reporting our sample statistic, okay? So when you report the mean, we reported the standard deviation, but you also should report the confidence interval to give that context about how that sample statistic fits, how confident you are that a sample statistic is actually part of the population parameters. And here's a parameter that we've calculated. All right. So that's the answer, 14 and 24. So the next question is, with 90% confidence, did they collect an adequate number of students to keep their margin of error? %. And then how about with the confidence interval? How about with a 95% confidence interval? So now this is the equation as you see up here, sample size of a proportion. And this is broken down for you really easily here. And again, you just plug and chug, okay? So we've got Z, and I'll tell you about Z in class, and we'll also talk about T, which you utilize when you have a small sample size, but we have big enough sample sizes to utilize Z. The population, or the proportion parameter, was 19. Remember that, so it naturally calculates this for us. It also naturally calculates the rest of the statistics for us. But then we said that this margin of error was supposed to be 5%. So you've got to put that in there, okay? And now this times itself, this squares itself, and we end up with this value over this value, which is what we see here. We see this, all of this over that e squared, which ends up being this. And I make it margin of error. Here it says e, so I'll just keep it consistent so you know exactly what it is. Okay, e squared. Okay. So it ends up calculating a sample size of 165, rounded 166. So the answer would be no. Okay. So then it says, how about with a 95% confidence interval? And what ends up happening to this number is it changes. Actually, I'm actually having trouble remembering it right now. I believe it's 1.9 It's all in the 1.96, yeah. Just wanted to verify that. Again, I'll teach this in class, 1.96, but it's also in the reading here where it talks about it in your I don't know where the reading went, but it talks about it in your reading. All right, so I just put 1.96 in there for the Z value because, again, that's what's connected to the confidence level. And now you see that as I increase my level of confidence, I'll need more participants in my sample. Okay, so the answer is no. In neither case did they collect an adequate number of students. Okay, they took another sample of 200 students at UCSD and 45% brand B, and based on the two samples, what/how will you answer the CEO of Soft Drink A's question? Should we invest in R&D to improve our soft drink or not? So CEO A's actually, it's 4:54. I've got to run class. So this will be done in two parts. I will finish up the rest of these in a bit. All right.